All right, let's try this again. Third time's a charm. All right, welcome back, everyone. You guys took your test. Great job. So, I am still in the process of grading it. I'll hopefully have the data up by tomorrow, Wednesday, and so we can go over it together. And what I noticed already is that you guys already did a much better job. So congratulations, good job. And what we'll do from here on out is we're just going to take that and we're going to build on top of it. Okay. So we just went over atoms and periodic trends. That was this last unit. Now our new unit is called chemical reactions. Okay. So you should have in front of you some notes. Okay. It should say like unit 3.1 notes and then like three quarters down it says something about 3.2. Those are the notes that you're going to need to have. The other thing that you're going to need is your periodic table because we are still going to be needing that and using that. And then the third thing is your vocabulary list. So now I know that for some of you, I had you guys write out the vocabulary from an article. If you have that, great. If not, that's fine too, because what I have been doing and been working on is I've been interweaving the vocabulary into our slides. Okay, so when you are going to be taking notes, you're going to want to make sure you have those three things out. So you're going to want to make sure you have your notes, your vocabulary, and your periodic table. Okay. So the first thing that we're going to be going over is not necessarily our 3.1 notes. It's going to be more so of our vocabulary from last unit. Okay. So the first thing that we're going to be talking about again is some of our terms here. Okay. And with your vocabulary, I don't know if you noticed, but it's not going to be in order. All right. So you're going to have to find it throughout your notes and your vocabulary sheet, and you're just going to have to fill it in. I apologize, but that's just kind of how the cookie crumbles. Okay, so here is our first term. Let's see what we remember. So our first one is we're talking about is valence electrons. Okay, so find valence electrons in your vocabulary, and then when you do, we're going to be writing down this definition here. This definition is the electrons on the outermost energy level or orbital of an atom. So let's say, for instance, that we have sodium. So sodium is element Na, okay? It has 11 protons and 11 electrons. All right, so here we're going to quickly draw a little Bohr model. All right, so it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then one more in the outer orbital makes 11. Okay, so your valence electrons are talking about the electrons on the farthest orbital only. So that means it's going to be this guy right out here. This is your valence electron. Okay. So the electron on the farthest orbital only. Okay. Now our next term here is talking about Lewis dot structures. So Lewis dot structures are very easy. Okay, and you're going to get real familiar with them if you're not familiar with them yet. Okay. So your Lewis dot structures are simplified drawings of how valence electrons are arranged around atoms in a molecule. So really, what all that means is, for example, we have sodium up here. If we do Na, which is our element symbol, and then just draw how many valence electrons it has, so 1, just like that, this here, that is your Lewis dot. All right. It's just like that. It's just your element symbols and then how many valence electrons it has. Okay. And remember that your valence electrons is the group number. Okay. So the group number that's above the whole entire column on your periodic table. Okay. Now our next one is the octet rule. So with this one, if I were you, I would probably circle it, I don't know, star it maybe put like a smiley face, right? Because our octet rule, this guy here, this is what we are going to be talking about a lot this unit, all right? So our octet rule is atoms prefer to have 8 valence electrons in the outermost orbital, and then the Y, it's to become stable. So you're going to have a question on your test and quiz and exit tickets and throughout this whole thing that's going to say what is the octet rule and why is it important. You're going to want to put this very definition here. So the atoms prefer to have 8 valence electrons in the outermost orbital. Why is it important? To become stable. Okay, so that's what we have there. Let me get rid of all this. All right. Here we have pictures. So again, this is our boron atom, and it's a Bohr model. And our valence electrons, it's what it's pointing at there. Our Lewis dot structure of carbon, so carbon is in column number 4, has 4 valence electrons. And then here, this is a covalent bond, but don't worry about it too much. This is just an example that says, hey, for instance, our chlorine that has 7 valence electrons, it's going to want to gain at least 1, so it'll have 8 to complete its outer orbital, okay? All right. So, Unit 3 are new-ish terms here. So we got ions, all right? So we talked about this before. So an ion is any atom or group of atoms that bears, which is wrong, bears, that's funny, one or more positive or negative electrical charges. Okay, so if it has a positive or negative charge, all right, it is no longer an atom, it is now a ion. Okay, so we have cations, right? So remember, cations, they're going to be our positively charged ion, right? And remember that we have our word that's cat, and cat makes us happy. All right, hey, little cat. Yay. Yeah, little cat guy. So, and they make us happy, all right? Then we have our anions. Our anions is a negatively charged ion, all right? So here's another way to remember it. So if we have our neutral atom, all right? Our neutral atom, these guys, if they lose electrons, they're going to turn into a cation. All right. So, which is mostly our metals. Okay. And then if they are going to gain electrons, these are going to be our nonmetals. If they gain electrons, they're going to turn into an anion. Okay. So here is now some new terms here. So what we're going to be primarily focusing on for this first part is our ionic bonds. So we've been talking about cations and anions and ions, right? Ionization energy even. So now this is talking about ionic bond, right? So this is this is a chemical bond formed when a metal atom gives up one or more electrons to another non-metal atom, okay? That's the key. So how are you, I'm going to ask a question, what is the difference between an ionic bond and a covalent bond? So you're going to want to go into your vocab and find these two terms here, okay? So an ionic bond is formed when a metal, so two key differences is about metal and a nonmetal, and how the metal atom is going to give up its electron to the nonmetal, all right? So those are your two differences. The other one is talking about covalent bond, which is a chemical bond formed when electrons are shared between two non-metal atoms, okay? So this one, your ionic bond is your metals and nonmetals. okay? And your metal electrons, they're going to be given to your non-metal atoms, okay? It's all about giving here. Giving metals and nonmetals. Now, a covalent bond, right? So you have your prefix co, right? So co means you guys probably heard of co before, like co-op, right? If you're a nerd like me and played video games with your friends, like you ever played a co-op game, right? You're playing them together. That's what co means. Co means together. So that means for covalent that if it's something is being shared, right? And if it's between, oh, dang it, Froggy. Sorry, my cat stepped on my screen. All right, so if it's, where was I? It's shared between two non-metal atoms. That means it's a covalent bond. Okay, and co means together, so that means two non-metal atoms are going to be sharing these electrons. Hopefully that makes sense. I apologize about my cat stepping on my screen. So here is a better picture. So we have our metal atom, right? So think of this as like if we have sodium that has one valence electron, and if we have chlorine that has seven, right? This here, this guy is going to give its electron over to chlorine here and it's going to make a bond. And when that does, this here is now gone, okay? Because now it moved over to the chlorine there. And when that happens, we now have our cation, right? So our cation, which is our metal atom, and then we have our anion, which is our non-metal. So um, if we were, so sodium here, sodium has 11. Okay, so when this electron is given away, it's now gone. It's going to disappear. All right, and that means this whole entire orbital is going to be gone. All right, and when that happens, it's going to go back to um, the other orbital. Right, it's going to go down to this guy here, which is going to have 8 valence electrons. Oh, that's bad. I had to do this. Oh well. All right. So we have our covalent bonds here. All right. Covalent bonds is between two non-metal atoms, and when they are paired up, they're going to share their electrons. And what's really cool about them is that it's going to double count for both atoms here, right? So I have these two. Okay, so for A, it has 2, 4, 6, and then this here counts as 8. For B, I have 2, 4, 6, and these here count as 8. Okay, so they're both satisfying their octet rule there. All right, so now what we're going to want to do is you're going to transition to your notes. Okay, you can then give you a second to get that out. So here's the thing with your notes. You might have noticed that, wow, there's just a lot of lines here. Okay. So I know that many of you guys are thinking about college. If you're not, that's okay too. But for college, I'm going to let you guys know a little ahead of time that your professors, they're not going to really care how you take notes. Okay. So as long as you take them. So this is just kind of like a little bit of practice for you guys to take your own notes. So you can do this in a few ways. All right. One, you can copy it word for word, which you totally can, but I'm letting you know there's a lot of words here. Okay. So you can either copy them word for word, or two, You can also shorten it and put it into your own words, right? So if you can figure it out, right, and put it in your own words, that's better. Because right now, all these notes, these are just my words. This is just what I'm telling you, what I think is right. But if you want to put in your own words and make it better and shorter, by all means, go ahead. And now the other way is to also draw pictures that go along with them. If you don't want to write like 4 or 5 sentences for a simple definition that can be easily drawn, go ahead, draw the picture instead. These notes are your notes, okay? So make sure that you do that seriously, okay? So here we go. So our first point here is that number one is going to go along with your number one on your notes. All right, so number one, it says an atom that gains one or more electrons will have a negative charge. So remember, if it's gaining an electron, electrons are negative, it's going to have a negative charge, right? We'll have more electrons than we will protons. Two, an atom that loses one or more electrons will have a positive charge. So if they're going to be losing electrons, they're going to have more protons than they will electrons. Okay. And then number three, an atom that gains or loses one or more electrons is called an ion. Okay. So we talked about it in the very beginning how an atom, when it gains or loses an electron, it turns into an ion, and then that ion is split into two different types of names. Those names are cation and anion. That's what number four is. So a positive ion is called a cation, and a negative ion is called an anion. All right. So on your paper, and what you're going to end up doing here, ouch, is I'm going to be giving you a little half sheet, all right? And with that half sheet, you're going to be basically kind of be playing a little scavenger hunt for a few of them. So the first thing is, for example, all right, our first name here is chlorine. So what you want to do is I want to make sure that everybody has it. So get out your periodic table, find chlorine on your periodic table, okay? If you've been ignoring me this whole time, because you're on TikTok and it's just a silly little video, I know, I get it, it's boring, but your education is important, right? So take advantage of your education now, and I promise you your TikTok will be there later. So please get out your periodic table and find chlorine. All right, chlorine is element number 17, if that helps you. All right, so once you find that, you're going to find the atomic symbol. So the atomic symbol in this case for chlorine is Cl. All right, Cl, capital C, lowercase l. So on your periodic table, it's going to be saying, hey, is it a metal, non-metal, or metalloid? In this case, chlorine is a non-metal. All right. So I'm going to draw a quick little picture here of your periodic table. Let's see if I can do it. Yay, see, that's not too bad. All right, so you have it kind of like this, and then if, let's say, like, I don't know, kind of goes something like that, all right, pretty close, not bad, I'd probably give like a 6 out of 7, All right, so we have, kind of looks like this, okay, you got your 1, 2, 3, 4, 5, 6, 7, and 8. Those are your column numbers, okay? So for the most case, this area, all right, so all of this here, if you haven't done so, all right, make sure that you write it down that this here is your metals. All right. So your periodic table makes up about 80% of your entire periodic table of all the elements. Okay. Then you have elements that are touching the staircase. So they go like, oh, that's a bad color. Let me do a different one. Let's say Sure, why not? We'll do this color. So they kind of touch the staircase going like this, okay, on opposite sides of it. All right, on your version of the periodic table, it's the lightest color, but these guys here, these are your metalloids. All right, or semi-metals. Okay, and then you have all these other elements that are like over here. All right, these ones here, if you find it, there is an element inside there, and it's called oxygen, which is like right here. Okay, so oxygen, that's a very important element for us. Why? Because we use that to to breathe. Okay, so if you're unsure, hey, if it's a non-metal, metal, or metalloid, if it's by oxygen, it's a safe bet to say that these guys over here, these are your non-metals. All right, because it'd be really bad if it was a metal that we were breathing it in. Okay, so that's just to kind of help you out, kind of remember. All right. So you're going to find it to figure out if it's a metal, non-metal, or metalloid, and it's going to be important for our chemical reactions unit here, okay? So remember, the total number of electrons for chlorine is also the atomic number. Atomic number, all right? So it has 17 total electrons. Then in the group number, right, so the vertical column is going to say, hey, it's going to have 7 valence electrons. All right, that's the group number. Okay, then the thing that you guys are going to need to figure out here, all right, is if you have, I don't know if I went over this, but let's say you have like a number line here. Okay, so we have a number line. So I have okay. So these numbers that I'm going to be writing down below, I'm going to write a 1, 2, or 3. These numbers here, these are your group numbers or your valence and electrons, okay? Or valence electrons. All right. So if your element falls in a group 1, 2, or 3, these guys are going to be your metals and your cations, which also means they're going to want to lose. They want to lose their electrons. Okay. Now, if they have a 5, 6, or 7, all right, these guys, these are going to be your nonmetals. Okay, your nonmetals, and they're going to want to, which is also your anions, and they are going to want to gain electrons. Okay, and they want to gain or lose because they want to complete their octet. So this is all about their octet rule here. Right, so our octet rule is coming back in action. So if we're talking about our chlorine here again, goes from, it has a nonmetal, 17 total electrons, its number of valence electrons is 7. How many more electrons is it going to want to gain in order to get to 8? So it's going to want to gain 1. All right, so it's going to want to gain or lose. It's going to want to gain 1, and when it does, remember, electrons are negative. We're gaining something that's negative. So we're going to have more electrons than protons, so that's where we're getting our -1 charge from. Okay? So now what's going to end up happening is you're going to get a little half sheet from Miss Palmer. She's going to pass it out to you, and then she's also going to set a 5-minute timer here, okay? Because what we're going to be doing is basically that for quite a bit. So complete the next 3 elements on your own. You're going to be doing potassium, magnesium, and fluorine. She'll give you a 5-minute timer to do so, okay? And then she'll resume the video, and then you're going to go over your answers and double check it, okay? Now, please take the time to double check it, all right? This is not, remember, no time for TikTok. TikTok will be there later, okay? I promise. It's not going to go anywhere, but you'll be all right. Now, what we need to do is we need to find these elements, though, okay? So Ms. Palmer is going to pause it here, and then after 5 minutes, she'll resume the video, okay? Alrighty, here are the answers, okay? So the first one is talking about potassium. So potassium is symbol K. So the element symbol K, it is a metal, has total electrons is 19, has 1 valence electron. It's going to want to lose 1 electron to have a 1 plus charge. Then we have magnesium, which is symbol Mg, which is a metal. It has total electrons 12. It has 2 valence electrons. It's going to want to lose those 2 to have a 2 plus charge. Now fluorine is a symbol F. It's a non-metal. It has total electrons is 9. Has 7 valence electrons. It's going to want to gain 1 electron and have a -1 charge. Very good. Good job, guys. All right, so now Miss Palmer is going to do the same thing. She's going to hand out another piece of paper. Okay, now it's practice part number 2. So you're going to do again, completing the next 3 elements. These next 3 are aluminum, sodium, and nitrogen. She's also going to start another 5-minute timer. Okay. Then, after that 5-minute timer, you're going to go over these answers. Okay, so Miss Palmer is going to pause the video, and then she'll give you your 5 minutes after she's done passing them out, and then you'll go over the answers. All right, so here you go. Alrighty, here are the answers. So, first is aluminum. Your symbol is Al. It is a metal. Total electrons is 13. Has 3 valence electrons. So remember, if it has 3 valence electrons, if it has 1, 2, or 3 valence electrons, it's going to want to lose those 3. So lose 3 electrons to have a 3 plus charge. Sodium. Symbol is Na. It is a metal. Total electrons is 11. It has 1 valence electron. If it has 1 valence electron, yep, it's going to want to lose that 1 to have a 1 plus charge. And we have nitrogen. Its symbol is N. It's a non-metal. Its total electrons is 7. His valence electrons is 5. So if it's 5, 6, or 7, these guys are going to want to gain electrons. So it's going to gain 3 electrons and have a 3 minus charge. Very good. Now, what's going to end up happening again for round number 3 is that Miss Palmer is going to hand out your third sheet, a half sheet of paper here. Okay, so this is your practice part 3. So these are the next 4 elements, which is oxygen, hydrogen, carbon, and iodine. You'll also get another 5 minutes as well. Okay, just to give you a little heads up, hydrogen and carbon, those guys are tricky. Okay. So just kind of keep that in mind that it's not always what it seems. Okay. Alrighty. I'll give you guys 5 minutes. And then Miss Palmer, after 5 minutes, will resume the video and you check your answers. Alrighty. So here we go. Your answers for oxygen is simple as O. O for oxygen. It is a non-metal. Total electrons is 8. Has 6 valence electrons. So since it has 6 valence electrons, we're going to want to gain 2 electrons, right? Because we want to complete our octet. When it gains 2 electrons, it'll have a 2 minus charge. Hydrogen here. Hydrogen is well, first symbol H. It is a non-metal, right? So hydrogen is the only one in that first column that is a non-metal. There's 1 total electron. There's 1 valence electron. So now, I know a lot of you guys think, okay, well, it's going to want to lose 1, right? Because that's what's been happening with all the others. But not this case. It's going to want to gain 1, right? So, which I know, it's very confusing, but think of it, okay? So if hydrogen only has 1 proton and 1 electron, if it loses that 1 singular electron, that's just a singular proton. That's very, very, very unstable. So instead, if it gains 1 electron, if you're looking at your periodic table, since hydrogen is element number 1, if it gains another electron, it'll have the same amount of electrons as the stable noble gas helium. Okay, so in this case, it makes more sense for hydrogen to try to gain 1 more electron to be stable, just like helium. Okay, so carbon. Carbon, the symbol is C. It is a non-metal. Total electrons is 6. It has 4 valence electrons, so this is where it gets a little tricky. So it's going to want to gain or lose 4. So carbon is a tricky one. All your group 4 elements are going to be kind of weird like this. For the most part, they're going to be involved in more so of covalent bonds. But in this case, if they're going to try to gain or lose electrons, it could go either or. Okay, so that's why we're saying gain or lose 4. That's a plus or minus. So then we have iodine. Iodine, the symbol is I. It's a non-metal. Total electrons is 53, but it still only has 7 valence electrons. It's going to want to gain 1 for a 1 minus charge. Very good. Alrighty, so here we are moving on to our 3.2 notes. Okay. So the first part here, atoms will transfer 1 or more electrons into another to form the bond. That's what's kind of going on here. They're going to want to give away their electrons to another atom, and when that happens, they're going to make a bond. Each atom is going to be left with a complete outer shell. Okay, so what that means is, well, you know what? I'm going to give you guys just a minute to write this down because we'll go over an example here in a moment and I will show you that. Okay, so, but the main idea is that each atom is going to be left with a complete outer shell. So an ionic bond forms between a metal and a non-metal atom. Okay, so that's, again, key here. So for our first example, we have sodium and chlorine. So what we have going on with sodium and chlorine is that sodium is element Na. You know what? Has 1 valence electron. Chlorine is going to have 7 valence electrons. Okay? So remember that here for sodium is Na, and if we're drawing the Bohr model of these guys, right, all these lovely valence electrons here, or not valence electrons, excuse me, electrons here. Then we have chlorine, which is also very similar, but a little bit different. So it's element number 17, so it's going to have 17 electrons. Okay, so what's going to end up happening here is that our sodium atom, which is element Na, it's going to want to give its electron over to chlorine here, and when that happens, it's going to make a bond. Okay, that means this here is no longer here, it's gone, it moved over. Okay, so what ends up happening is that if you count, chlorine now has 2, 4, 6, 8 valence electrons. It makes it very happy, right? And what happens with sodium is that then this one is gone. That whole orbital now, this whole thing, act like it's not even there. It's gone, okay? You're only looking at now the new valence orbital, right? Now, sodium now also, because it gave away that electron, now the outermost orbital has 2, 4, 6, 8 valence electrons, okay? So that's what's happening here with ionic bonds. They are metal atoms. They're going to be giving away their electrons to our non-metal atoms here, okay? And when that happens, they're going to make a ionic bond. All right, so the ionic bond. So what is an ionic bond? Well, that's a great question. So let's find out. So an ionic bond is when a metal atom gives its electron to a non-metal atom, making the metal a cation. Metal is cation, and the non-metal an anion. Okay. So how do you draw an ionic bond? Step 1, draw the Lewis dot structure of the atom. So, like I said, if you haven't gotten used to drawing Lewis dot structure, you're going to get very used to it now. So, remember how I said earlier that you're going to want to either write it word for word, shorten it up, or even draw a picture? Okay, this is kind of where it comes into play because this next one, I know it's a lot, and if you want to write it down word for word, by all means, go ahead, but you do not have to. Okay, you can shorten it up, and you can even draw a picture. And if you know correctly how to draw a Lewis dot structure, that's great. By all means, just draw a Lewis dot structure. Now, the thing is, on your test, like I graded them very easily. Okay, so for example, let's talk about let's use oxygen as an example. All right, so I'm giving you oxygen. All right, this element number 8 has 6 valence electrons. Okay, now the appropriate way is to imagine that we are placing our electrons, our valence electrons, down one at a time as if we're placing them like on a compass, okay? So you have a compass here. It's north, east, south, and west, okay? And what you want to do is you want to place them down one at a time. So that would be like 1, 2, 3, 4, okay? And you're going to go clockwise, right? So clockwise. It's the same way we're going to do with your oxygen here. So we're going to go first time around, 1, 2, 3, 4. Okay, so oxygen needs to have 6. So now we have to go our second time around. Second time around, and this is where we're going to be making pairs. So we're going to go 1 and 2. Okay, what I've seen way too much on our test and things like that, if you have oxygen, and I've seen people go like 1, 2, 3, 4, 5, 6. No, that is incorrect. We do not do that. Okay, that's going to make it very difficult. You're going to get confused really, really quickly. Don't do that. Go around clockwise. Okay. So clockwise, that's what we want to do. All right, so that's basically what I put in words, all right, is that method there. So if this picture works great for you, do that. If not, here you go. Here's the full words here. So while drawing the Lewis dot structure, let me get rid of this stuff. Start by drawing the element symbol of that atom. Then start at the top, placing dots, and go clockwise, one at a time, as if you are placing them on a compass. Then make lone pairs by going clockwise a second time. Okay, so that is what you could write word for word. You could draw the picture. It's totally up to you. Now, the next thing is you guys see this here where we have an underline bolded with a little asterisk star here. All right, this is a new vocab word. Okay, new vocabulary word. So make sure you have your vocabulary notes out. Okay, and your vocabulary word is going to be this. Lone pairs. A lone pair is when electrons form pairs that do not bond with another atom. Okay, so the key word is do not bond with another atom. So if we had our oxygen again, we had 1, 2, 3, 4, 5, and 6. These guys here, these are your lone pair of electrons. Lone pair. All right. All of our electrons, they want to form buddies. All right. So once we go our second time around, they start making lone pairs. All right. So these ones, we're not going to touch those. All right. They make your lone pair. All right, step 2, identify the lone pair of electrons by circling them. This means they are not being manipulated. You don't have to, honestly, you don't really have to circle them, but this is just an idea in case you do get confused later on. So we don't want to touch our lone pairs. That's the main idea here. Okay, don't touch the lone pairs. Once you start going around your second time in your Lewis dot structure, you just leave those guys alone, right? We're looking at our single electrons. Those are the ones that are going to be making bonds. Okay. Step 3, you got to make sure you have your figure out what electrons are single, right? So identify the electrons that do not have an electron pair. Those are the ones that are going to be either giving away electrons or going to be taking them, all right, pairing them up. Step 4, draw an arrow from the metal atom's electron to the empty spot near the non-metal's single electron. These electrons make bonded pairs. So here, for another quick little example, we have, again, our sodium and our chlorine. That has 7. If you notice, I went clockwise around, right? So the lone pairs we aren't going to touch. What we are going to touch is the valence electrons from sodium. So this guy is going to go and move over here. Okay. And when that does, now this is gone, moved over. And here, this makes a bond. Okay. Now those electrons, they are a bonded pair. So, and again, we have our asterisks and our vocabulary word. So let me get rid of all this again. Bonded pairs, these occur when electrons form bonds with other atoms' electrons. Okay, so those here, again, I'll rewrite it real quick. Here, this moves over. That here, that is your bonded pair. Okay. Your bonded pair, that's when our sodium is giving away its electron over to chlorine. That's our bonded pair. Alrighty, to continue on. So if we have one atom with a complete octet and another atom with a remaining electron, we have to add another atom on the opposite side until all atoms have complete octets. Well, that's great, but what in the world does that mean? Okay, because that's kind of confusing. So let me show you. If I have an example, magnesium, Mg, and it has two valence electrons, and let's say it's going to bond with our chlorine atom, right? What's going to end up happening again is our magnesium is going to give one away to our chlorine over here, and it's going to make a bonded pair, right? So that's gone. All right, but we have an issue, okay? Now, if you see here, this whole chlorine atom has a full 8, right? Which honestly, that satisfies the octet rule for that chlorine, right? But the thing is, our magnesium isn't satisfied. It doesn't satisfy its octet rule. So, which if you see here, we know that because there's one more left over, okay? So this idea kind of gets a little bit confusing, right? Because what we're going to have to do is we're going to add another chlorine atom. All right. Now we can move this one over. It's going to make a bond here. And when that does, now that's going to be gone. Okay. And now this is no longer a frown. They're going to be happy, right? So all of our chlorine atoms will have 8, and our magnesium atoms will have none, right? So our metal atoms will have none, and our chlorine atoms will have 8. That's what we want to do. That's what step 5 is talking about. So really what we're going to be doing is we're going to be adding our metal atoms, and we're going to be adding our chlorine or our nonmetal atoms until all of our nonmetals have 8 and all of our metals have none. Okay, so that's our goal. Once we get to this spot here where we can't move, there's no way we can move any more electrons around, that's when the reaction stops. Okay, it's going to get very weird and you're going to feel like, wow, this can go on forever, but it won't, I promise you. Okay. All right, so step 6. When you get here, you should have nonmetal atoms, a complete electron shell, and metal atoms with an empty one, which is exactly what we have here, right? So this chlorine atom has a full 8. This chlorine atom has a full 8. And then we have this magnesium atom that has none, okay? So once that's right, you're all good to go on to the next step. Now, the next step here is step 7. So what we want to do is we want to write the charges for the new cation and anion. These charges are placed in the superscript. Okay. So what we have here is the charges. So we're talking about, for example, how many electrons did magnesium lose? Okay. So magnesium is element number 12. And it lost 2 electrons, so that means it has 10 electrons left, okay? If you do the math, 12 minus 10, and that gives you 2, so what we're going to have here is that magnesium is going to have a 2 plus charge, okay? That's 2 more protons than it does electrons. Then, if we're looking over at chlorine, how many electrons did chlorine gain? Now, I have an idea that you're going to say it's gain 2, but not necessarily. It gained 2 in total, yes. But how many did just one chlorine atom gain? Okay. And the correct answer is just 1. So what we would do is we just write 1 minus sign above it, right? Just like that. That tells me, hey, those chlorine atoms, they gained only 1 electron each. And the superscript, that is where we place them. So for vocab, what in the world is a superscript? You guys all know what superscripts are. So a superscript, this is where we write the charges above and to the right of the element symbol. You know what a superscript is. You done them. You wrote them probably 100 times more or so in math. Remember, it's another way to think of what a superscript is an exponent. So if you have, like, remember, x times x, that is just x squared. That is your superscript. Okay. Another way to think of a superscript, right? You guys heard of Superman, right? He's a man that's above you, right? That's what super means. Super means above. So a superscript is above, and script means writing. Okay. All right. So here we have step 8. What you want to do is you want to write the binary compound. And what the binary compound is, it's a chemical compound made of exactly 2 different elements which are chemically bonded. Okay, two different elements which are chemically bonded. So, like what we've been talking about with our sodium and chlorine, and we give it over here. Now this is gone, right? We get a binary compound, so it's exactly 2 different elements which are chemically bonded. Okay. All right. Our next step here is, how do we write an ionic binary compound? All right. So this is what we've been kind of just writing this whole time. But now this is our next part here. So how to write an ionic binary compound? Step 1, you must write the metal element symbol first. Okay. So if we had, bringing it back to our magnesium that had 2, right? And it had chlorine that had 7. We give one away, makes a bond, that's gone. Draw another chlorine. All right, that's going to be given away over here. It's going to make a bond. I know it's messy, I'm sorry. That's going to be over here. So now what we need to do is first, we write the metal symbol, metal element first. So we would write Mg. Step 2, if there is more than one of the same type of atom used to complete the octet of the nonmetal, you must write how many were used in the subscript. Okay. What that means is, if we have more than one magnesium atom, we would have to write how many that we use in the subscript. So a subscript here, all right, a subscript, if superscript was above, subscript, like a submarine, would be below. Okay, so this is the area that is on the bottom right corner. This is typically where we write how many atoms are being used. So I had Mg, all right, and then I had, this is being shared to 2 different chlorine atoms. Once all the metal atoms are accounted for, so I had my Mg, I only used 1. Then write the element symbol for the non-metal. So this is where we're going to write our chlorine. So we have Cl. And just like before, if there is more than one of the same nonmetal used to complete the reaction, you must write how many were used in the subscript of the nonmetal. So the subscript is where going to be used. And remember, see how I used 1 and then 2 chlorine atoms? So I'm going to write it down here in the subscript. Okay, so that is your subscript. That's where you're going to write it. All right, so this is your chemical compound, or what you're going to be getting at the end. All right, so let's practice the sodium and chlorine. So we've done this one quite a bit, but just to kind of re-practice it, yeah, I'm gonna use a different color. I got sodium, I have chlorine. Sodium has one valence electron, chlorine is gonna have seven. Our metal atom is gonna give away to our non-metal atom, making a bond. That's gonna go away. Our charge for our sodium atom in the superscript is going to be a plus. Our charge for the chlorine atom in the superscript is going to be a minus. And then to write it out, what we're going to write is NaCl. So let's try practice with magnesium and fluorine now. So if I have magnesium, which is Mg, as 1, 2. Fluorine is 7, so 1, 2, 3, 4, 5, 6, and 7. 1 is going to be given, it's a different color. 1 is going to be given away to fluorine, making a bond. That's gone. So, are we done? No, of course not. Why would that be done? So we're going to draw another fluorine atom because magnesium isn't satisfied yet. 1, 2, 3, 4, 5, 6, and 7. This one is going to be given over here. That makes a bond. That's erased. So now we have magnesium, which lost 2 electrons. So if it's losing electrons as negative, it's going to have a 2 plus charge. Our fluorine atoms in the superscript is going to have a minus charge because they only gained 1 each. Okay. To write it out, we write the metal, so magnesium. We only used 1. Then we write fluorine, okay? Then we write how many fluorine atoms we use. So there's 1 here, there's another one here. So we write MgF2, okay? Then we have calcium and phosphorus. So we have calcium and we have phosphorus. Calcium has 2 valence electrons and phosphorus is going to have 5. All right. So with these ones, these guys, I'm telling you, please take your time. Don't try to rush it. Literally draw it one arrow at a time so you don't get lost or confused. You're going to have to draw your Lewis dot structures accurately as well. Okay. So like I've been doing, these are going around in a circle. I'm going clockwise twice. Okay. Please, I cannot stress enough, make sure that it is organized in a decent way so you can see where all your electrons are going, okay? I'd probably make your electron dots a little bit bigger so you can see them. Please don't just make a little tiny speck and make it feel like you can see it, okay? Make it bigger so you can see where these electrons are going, okay? So here we have calcium is going to give 1 electron over to phosphorus here. It's going to make a bond. Now that electron is erased. It's gone. It's moved over. And then we have another one. It's given it's over here, this side. That's erased and gone. Okay. So calcium's all satisfied, but our phosphorus is not. Okay. If you look closely, it only has 7. So that means, you guessed it, we have to draw another calcium atom. I got 1 and 2. 1 electron is going to be moved over here. It's going to make a bond. That electron's gone. Okay. Well, now phosphorus is satisfied, but is calcium? No. So that means we're going to have to draw, again, another phosphorus atom. 2, 3, 4, and 5. Our electron is going to be moved over. It's going to make a bond here. That is now gone. Okay. Now, we have 2 calciums that are satisfied, 1 phosphorus that is satisfied, but now our second phosphorus isn't. So we're going to have to draw yet again a final calcium. So I got 1 and 2. This calcium is going to give it over to here, make a bond. That's gone. And we have this one over here, makes a bond, and now that's gone. So now if we look, calcium, all of our calciums are gone. They have no more valence electrons. And all of our phosphoruses, they have a full 8. Okay, so that means we are now finished. So what kind of charges do we have here? So our calciums, if you look, they only lost 2, so they have a 2 plus charge. Okay, and then how many did our phosphorus gain? So if they're gaining electrons, they're going to gain a 3 minus charge. They gained 3 electrons. Okay, so 3 minus, there we go. So now all that we do, first you write the metal. So we write calcium, so Ca. How many calcium atoms do we use? So I'm counting 1, 2, 3. So you're going to write a 3 in the subscript below. Okay. Next we write our phosphorus, so P. And then how many phosphoruses do we use? That's circled in orange. I'm counting 2, so it would be 2 here. That is our chemical formula for that. Okay, so that is our notes, I believe, for 3.1 and 3.2. Okay, you're going to be given a few half sheets for practice. You're going to be given first the beginning level, which is all simple. It's really easy. It's just the metal is giving it over to the non-metal one at a time. You'll see that. And then you'll be giving the mastery level next, which is kind of weird. But through discovery, we found out that the mastery level is actually a little bit easier than the intermediate level. So you'll be given the mastery level next. And then after that, you'll be given the intermediate level, and I can make another quick little video of that, just kind of going over those answers. Okay. Remember, if you have any questions, please, please, please come over and ask. All right. This unit is tough, and I'm not going to sugarcoat it. It's probably going to be even more tough with, like, you know, since I'm not physically in there and this is just a little video. So please, please, if you do not understand it, okay, please, I'm literally asking you to come on over and ask me for some help or something, or how to clarify. I'm literally in my room after school every single day. You can come during advisory. Just please, just make sure you ask for help. That's all that I'm asking for, okay? If you do that, if you understand this, and if you're getting it, great. But if you still want to come on by, you're always more than welcome to. My door will always be open. Okay. If you need anything, like I said, come and ask. Okay. Um, I will talk to you guys later. And if you need anything, please come and ask. Alrighty. Mr. Buchanan is out.